Hello and salutations, my good people. My name is Mark Herman.
And I'm Tanya Chatelain, and today we'll be demonstrating on one of the common tools used in the laboratory, the bioreactor.
Okay, the bioreactor is broken into three main components. The first component is the actual bioreactor. The second component is the desktop. And the third component is the laptop. The bioreactor is an apparatus used to grow organisms, such as yeast, bacteria, and mammalian cells under controlled conditions, such as pH, dissolved oxygen, and temperature.
There are three types of bioreactors: fed batch, and continuous. For our purposes, we will be using the batch bioreactor, which is connected to this top piece located on the head plate, is used to power the stirrer. The stirrer mixes the contents within the vessel to supply oxygen and nutrients to the cells at a constant pH and temperature.
The three probes are used in the bioreactor is the dissolved oxygen probe, the temperature probe, the pH probe.
Now that we're done explaining the bioreactor, we're going to explain the desktop. We're going to break the desktop into two parts. The first part is located right here, and this is used to maintain the levels of air, oxygen, nitrogen, and carbon dioxide, which are all components needed in cell media. The second part is used to maintain pH and the antifoam levels. Acid is added if the media becomes too alkaline, and base is added to maintain the pH if the media becomes too acidic. And antifoam is added because when the cells are being mixed, foam accumulates on the top of the media. And in order to decrease contaminations, you use antifoam.
The software we're using is Biostat 8+. To activate the software, just click on a PC panel icon. This software communicates with the desktop in order to regulate the set parameters with the bioreactor. For this experiment, we already made our broth, and we already autoclaved it in the liquid cycle, as you can see with the markings here. Alright, now we're going to autoclave our bioreactor. So first step is we're going to cover any opening ports with aluminum foil, like so. Okay. Now for the bioreactor, we're going to open the door lid here. Take out any trays that are in there already. Put it in the bioreactor. Close the autoclave, tighten it up, and we're going to put it in the dry cycle. Ding! Alright, our autoclave is finished. Alright, we're going to unscrew it here, open it up. We're going to take out our bioreactor. Alright, that's an autoclave. Alright, we'll take it over to the table here. Alright, we're going to get our trusty funnel here that's been autoclaved. We're going to open one of the ports, put in the funnel here, open up our LB broth, and slowly put in our LB broth. Making sure we don't put too much at one time. Now that we put all our LB broth in, next step, let's remove the aluminum foil from the mortar and install the mortar itself. Sure it's screwed in there. Alright, next step is we are going to put our tubes for the acid and base. We just finished connecting our acid and base tubes. For our acid, we're using 1 molar hydrochloric acid. And for our base, we're using 1 molar sodium hydroxide. Easily just match the tubes according to the acid or base and follow the arrows according to the acid or base. Real simple.
So after pouring our media into the vessel, we're going to use our pre-inoculum and inoculate our media. Using a serological pipette, to pipette a certain amount. And using one of our ports, we're going to put the cells in there. Because without the cells, you have no growth, just media.
Put our probes. We're going to get 70% ethanol, wipe it down, and we're going to wipe down our probes and insert our probes according to the proper port. Once we have our probes set, we're going to set our parameters, our temperature, pH, dissolved oxygen, antifoam if any, CO2, and then after we do that, we'll go to our stair, set our RPM, and then we'll go to auto and hit OK. So once we hit OK, as you can see, our stirrer is already getting the job done.